This is multivariable calculus 3 problem. Find the absolute maximum and minimum of the following multivariable function z equals f of xy. Express the answer as an ordered triple xyz. Okay, so z is equal to f of xy equals x squared minus 2xy plus 2y, and on the region R where x is between 0 and 2 and y is between 0 and 2. So we are keeping this problem simple function, simple multivariable function, and simple region between 0 and 2, because we want to focus on the process, on how to solve step-by-step process. So here is detailed solution step by step. So the first thing is we want to draw the region where x is between 0 and 2, y is between 0 and 2. And here is the region. The region is x is between 0 and 2 and y is between 0 and 2. And this is the function z equals x squared minus 2xy plus 2. This is three-dimensional graph of the z, where the x is the red axis, x-axis is the red, and y-axis is the green, and z-axis is the blue. Okay, so that means our solution to this function lies in the region which is this box and its boundary. So all the solution lies inside this box and its boundary. At the same time, the critical value, the maximum and minimum which we are looking at, lie at the corners of the box, or the critical value of the function z, or the critical value of the boundaries. The boundaries are L1, L2, L3, and L4. That means it is important to find the boundaries L1, L2, L3, and L4, and their critical value, because the maximum and minimum are going to lie either at the corner points or the critical values of the boundary or the critical value of the function itself. Okay? So the next step is then determine the lines and any critical values of z equals x squared minus 2xy plus 2y. Okay, so now let's look at line 1. So line 1, as you can see, x varies from 0 to 2, but y is always constant 0. That means L2 is f of x 0, y is 0. So that is x squared minus 2x times 0 plus 2 times 0. So that is just x squared. And the derivative of x squared is 2x. When you set that equal to 0, it is x is 0. That means the critical value of this line is at 0, 0, which happen to be at the corner 0, 0. Now let's look at line 2. In line 2, as you can see, x is always 2, y varies from 0 to 2. That means this is f of 2y. X is always 2. So that is 2 squared minus 2 times y plus 2y. So that is 4 minus 4y, 4 minus 4y plus 2y, which is 4 minus 2y. And the derivative of this with respect to y is minus 2. This is a constant, so that means there is no critical value here. The next line is L3. L3 is, as you can see, y is always 2, x changes from 0 to 2, so y is 2. So this is f of x 2, y is always 2. That means this is 2 squared minus 2 times x times 2 plus 2 times 2. So that is x squared minus 4x plus 4. And the derivative of that with respect to x is 2x minus 4. That means x equals 2. So the critical value of this line is at 2, 2, which happen to be the corner point. Okay. Then L4, as you can see here, L4, x is always 0, y varies from 0 to 2. That means this is f of 0y. So that is 0 squared minus 2 times 0 times y plus 2 times y, which is 2y. The derivative of this with respect to y is 2, which is a constant. There is no critical value here. Now let's find the partial derivative of z, which is x squared minus 2x y plus 2y. The partial derivative with respect to x, which is f of x, is equal to 2x minus 2. X is the derivative of x is 1, y is just a constant. So this is 2x minus 2y, and set that equal to 0. That means y equals x. And also find the partial derivative with respect to y. So x is now constant, that is the derivative of x squared is 0, it is a constant. Then this is minus 2 times x, this is constant, the derivative of y is 1, so that's minus 2x plus 2. Then this is, set this equal to 0, that gives you x equals 1. And we say y is equal to x, that means y is also 1, so the critical value here is 1, 1. Okay. Now we have all the corner points and all the critical values. Now we need to create the table of corner points and critical values and identify the maximum and minimum. And here is the table. Z equals x squared minus 2xy plus 2y. The corner points are 0, 0, 2, 0, 2, 2, 0, 2, 1, 1. Those are the corner points and critical values, critical points. Okay. So at 0, 0, it is 0 squared minus 2 times 0 times 0 plus 2 times 0, which is 0. At 2, 0, it is 2 squared minus 2 times 0 plus 2 times 0, which is 4. At 2, 2, it is 2 squared, which is 4, minus 2 times 2, which is minus 8, plus 2 times 2, which is 4. 4 plus 4 is 8, minus 8, which is 0. At 0, 2, it is 0 squared minus 2 times 0 times 2 plus 2 times 2, which is, this is 0, 0 plus 4, which is 4. At 1, 1, this is 1 squared minus 2 times 1 plus 2 times 1, which is 3 minus 2, which is 1. Okay. Now looking at the table, obviously 4 is the maximum, 0 is the minimum. Also at the same time, 4 is the absolute maximum and 0 is the absolute minimum, because those are the highest and the lowest points in the region. And that is the answer. So the solution are 2, 0, 4 and 0, 2, 4, those are the absolute maximum, and 0, 0, 0, 2, 2, 0 are the absolute minimum. And thank you. Please subscribe, share and like, and ask your friends to subscribe, share and like.